Hi everyone, welcome back to Cody'sLab. So today I'm going to build a liquid oxygen condenser. The idea is I'm going to have something that I can put liquid nitrogen in, and then a thin tube, in this case copper, that I can run oxygen gas through to liquefy the oxygen. Pretty straightforward. Let's get to it. So I have this propane cylinder which is empty, and I'm just going to cut the top off of it here to make a cylinder that I can fill with liquid nitrogen. I'm of course going to have to insulate that. I was originally planning on using a stainless steel drinking flask. You see, if you have one of these cut open, you can see it's got an empty space in there which is normally filled with absolutely nothing. That forms an insulated barrier that keeps your drink warm or cold. Also, stainless steel is really good at dealing with very low temperatures, but unfortunately stainless steel is apparently very difficult to weld or solder to, so steel will do just fine. There we go. That's cut off. Now I've got my cylinder. The cut could be straighter, but it'll work. So there's my coil, as you can see. Looks pretty nice. It's a little dirty, but it should work. And here's the can, of course, that I'll be putting the nitrogen in. I've got to put a little hole in the bottom of this to feed the coil through, because this is going to be down inside of the can, just like that. This little thing on the bottom, there's a piece of metal right there. Now, I was going to just pry this off, but on closer inspection, it looks as though it's actually brazed on there. Yeah, you see down in there? There's a little bit of brass that has weeped through the metal. So, that's not going to really pry off. And really, since it's been brazed up with brass, it shouldn't cause me any problem, because I'm going to be brazing this in there anyway. Let's see if I can braze this up without melting through that thin copper tubing. There we go. I think that's going to seal pretty well. Just touch this up a little bit right there, get a pinhole. There. Now that I have this thing mostly complete, it's time to clean it up so that I can use oxygen in it. This tubing came from a mini fridge, and so I probably have a little bit of the pump lubricant inside the tube, so I need to get rid of that because it could react with the oxygen. So I'm just going to run some acetone through there to dissolve it away and flush out any oils. Now, of course, acetone is also flammable, so I'm going to be putting this into the oven for a little while to bake it and drive off any acetone and possibly anything else that I can bake out. Now it's time to insulate it. I'm going to use a combination of styrofoam pellets and expanding foam. So I'm going to set this down inside of this 2-liter bottle. I'm going to fill the inside of the bottle. So I'm just about ready to put this thing to the test. As you can see, I've got it hooked up to this oxygen bottle there. This nitrogen is colder than the boiling point of oxygen, so it should be able to condense it. It's going to take a while for this to cool off. To solve that problem, I'm going to poke a hole in the bottom of this little thing. I mean, this is only temporary, so that wasn't meant to be the permanent base for this. So it shouldn't be a problem in the future. It's submerging most of the coil. That should be good enough for this test. Okay, so I'm turning the oxygen on now. Let's see if we get any liquid to flow through. I'd say that is. Yeah. I got liquid shooting out of there. Excellent. I turn this oxygen off. It should stop flowing through. Let's see what happens if I just blow through it. And it's actually sucking air through this tube just naturally, and it's liquefying the oxygen in the air. That's cool. I did not expect that result. Let's see what happens if I blow the air through it. It's kind of cool to see the air that I'm blowing through it coming out as a slow trickle of liquefied oxygen, which is also being sprayed out with the nitrogen that doesn't liquefy. It's kind of cool to see that that's the amount of oxygen that's in the volume of my air in my lungs. Of course, there's also water and CO2 that I'm blowing out, which is probably getting froze up inside of the coil, which is not good for it. In fact, I'll probably have to let this completely thaw out before that comes out of the system. So here's a really strong magnet, and here's my oxygen I produced. As you can see, it is actually magnetic. It's highly contaminated. There's probably a lot of water, ice, perhaps CO2, or even argon floating around in there. But that is oxygen. I could filter that out and use it for various things, including rocket fuel. So I'm amazed at how much air this thing draws through itself passively. I can actually hear the nitrogen bubbling down in the test tube as the air gets sucked through. The nitrogen leaves as a gas, but the oxygen gets trapped as a liquid. Let's show you how much I've made after just a few minutes of letting it sit here. See, I had to put a tube on that to help with getting it into the test tube. Just pull my test tube of oxygen out of there. There it is. You can see it's still contaminated with ice and other things. Watch what happens when I ignite a little piece of paper that's inside the test tube of oxygen. Well, that's embarrassing, isn't it? So I had to think about it a little bit, and the reason that the piece of burning paper didn't immediately ignite when I put it in the test tube was because the oxygen that I was producing with the air was highly contaminated with liquid nitrogen. You see, the oxygen does boil at a lower temperature than nitrogen, but it's not a hard cutoff. It's kind of a gradual change between liquid oxygen and liquid nitrogen. And so when it's at the liquid nitrogen temperatures, liquid oxygen could dissolve half its own volume in liquid nitrogen, which appeared to be the case. Once most of the nitrogen boiled off, I could get the paper to ignite, however. So yeah, there it is. It does work, although it does seem that in order to get a pure oxygen product, I'm going to have to use a pure oxygen source, which makes sense, but that'll be a problem that I'll be solving soon with my hydrogen generator, which will be producing oxygen as a byproduct. And also, I'd like to mention that it is consuming nitrogen in order to produce the oxygen. It's like I'm trading liquid nitrogen for liquid oxygen, but that's because I can purchase liquid nitrogen. I cannot purchase liquid oxygen. I have tried, and the welding shops that will not sell it to me. Another thing that I've kind of realized after watching back the footage is I'm doing this right next to my methane generator, and you might be able to hear it burp every now and then, as it is producing gas at this point. So it might be a bad idea to be having open flames so near it. But of course it is currently producing CO2, so it's not a problem at the moment. And also this garage is fairly leaky. A lot of the windows don't seal properly, so the gas doesn't really build up. Anyway, hope you all enjoyed. I'll see you next time.